Welcome back to DIY Game API. DIY Game API.
DIY Game API. DIY Game API. DIY Game API.
DIY Games API is a series where we break out of this confinement that game companies are putting us in. They're putting us in this small box. Us developers like connect everything around us, and that's why we have our wireless RGB lights and our relays and our power outlets. And the main reason why we get Raspberry Pis and Arduinos, it's so that we can connect and make whatever our minds can think of. We don't want to rely on others in big corporations to create integrations, because the reality is that it may never happen. So DIY Games API will open up our minds and our games to show that even if something doesn't have an integration, we can make one. The way to get around this is, one way is using something like called a cheat engine, where it detects memory locations and find the differences between that memory location. But the thing with that is that games can detect that. Well, they can detect the cheat engine app. And when they detect something like that, they can ban you from their game. And it's very dangerous. And maybe you can make your own, and I haven't looked too deep into that. I'm not gonna risk it. So how do we get around this? This is where computer vision comes in handy. Computer vision is gonna be something that games cannot really detect. There's nothing really can really detect it. Because for the most part, you're gonna be taking screenshots every few milliseconds. So say if you wanted 30 times per second, that'll be 30 frames per second. Every second you're taking 30 screenshots. And in each one of those screenshots, you could try to detect something in that screenshot. And then you can do whatever you want away from the game. The game never knows what's going on, never knows what's happening, because you already took the screenshot, and that's all you need. One of the handiest tools that we're going to be using today is template matching. Now, template matching is scale invariant and rotation invariant. So say if you have this old Xbox 360 controller, right? Say if you're trying to detect this on the screen. If I'm holding it up straight and I take this screenshot and then take a crop out of this, it should be able to find this with no problem. But let's say I turn it just a tiny bit. This is where template matching is not handy. You're not gonna be able to use template matching for stuff like this unless you wanna come up with some like crazy algorithms where you're detecting literally every type of position. One problem that will solve this is feature detection. Feature detection, you can take out pieces, so you can take out this X button, and no matter where it is, you'll be able to find that X button. But we're not gonna use that. We're using template matching because we know that all of our things will be static and they'll always be the same for the most part. And this is where template matching shines. It's gonna shine where you have something that's consistent, like a GUI, or something that's consistent like, you know, a game. Like today we're gonna look at Fortnite. So you know we're always gonna have that eliminated sign at the bottom of the screen. That's what we're gonna be looking for. And that's where we can do whatever we want with that after we detect that. That's the spill on the DIY Games API series. So let's get started. Today we're gonna be looking at Fortnite, and we're gonna be detecting a kill when it happens, as soon as it happens. We have our globe again, our hue globe. We got this back again, and we're going to be reacting to this whenever we get a kill. Anyway, let's pull up Fortnite and let's get started. I used to be pretty decent in shooting games. I just don't know what happened. My last decent shooting game was Modern Warfare 2. But since then, it's been boo-boo, been so trash. I think it was the Battle Royale genre. It kind of like revealed who was actually decent and who was just, you know, horrible. I'm guessing I was one of the horrible ones, and I didn't know until now. Nice, we got one kill. Sure, I'm on the roll now. We might as well get a few more. Hey, I don't know what to really say. I did pretty good that game. So now that we have our clip, we're gonna wanna look for a time where we get a kill. Once we get a kill, we're gonna wanna get that template. So we're gonna pause it right when we get a kill. Here's one. So right now we see this eliminated right here, and some consistent things that we see is the bottom left, we have AHA code exploded. So we're always gonna see that AHA code in the bottom left. We're always gonna see this eliminated in the middle. And then we also have the kill streak over to the right, where we can use OCR. But right now we're just gonna use this eliminated right in the middle of the screen. Normally when I'm looking for a template, I would like it to be dark. I would like the background to be dark, because the template is gonna take into consideration everything that you crop as a template. So normally if you have a dark background, that dark background, when we turn in grayscale, the dark pixels will be the background and the light pixels will be the foreground. So normally when I'm looking for a template, that's what I'm looking for. So I already actually grabbed the template out of this video. Here it is right here. So it's kind of dark. It has eliminated with the grass in the back, and then it has her pants on the side, which is okay. It's not too many different colors going on. If you pick a bad template, you're gonna have a lot of problems. Try your best to look for a solid color and then a darker color as well. And then you shouldn't have too many issues. This simple.py is just gonna look through, it's gonna grab our template and go through each of these tests. So here's our first test, simple.py. So that test worked. So I already tested these, I know they're working. Let's try to hurry through the code. So we're grabbing our image, resizing it, we're changing it to grayscale, we're also doing the same thing with template, and then down here is where the magic happens. The cv2.match template is gonna take in the image, the template that you wanna try to find in the image, and then what kind of formula do you want to use to determine a match. So how template matching goes is that it's gonna start at the top left of the screen and gonna go down to the bottom, it's gonna go bottom left, right. So it's gonna go like this and find down here. So each place that this template sits in is gonna run a formula on it. So this formula, so right now we're using CCOEF norm, which is gonna normalize our values to be 0 to 1. And so the closer to 1, the more perfect the template is. You're not really gonna find a 1 unless literally that's where you got the template from. So you wanna have this threshold. This threshold is way too low. So 7 or 7.5. I normally go like 7 to 8, depending on what I'm trying to find. Since I didn't take a lot of time trying to find the template, I'm gonna keep it at 7. So we're gonna find all the values where the result is greater than the threshold. And then if we find any point, any match, because it's not gonna just stop at whatever match it finds. So if it finds a match in the top right corner, it's still gonna go through and try to find all of the other matches. So we wanna find any of the matches. And if any of the matches are greater than the threshold, we wanna print it out. And then we wanna put a rectangle around it. So you see when we ran the code. So if you see us running the code, it found it right here and then it wrapped a rectangle around it. So this live.py is where we're gonna run through as many times as we can through a while loop and get a screenshot each time of our screen. So we're probably gonna get around like 5 to 15, maybe 10 frames per second because we're not optimizing right now. Yeah, so we're gonna do the same thing that we did with the image. So that image is gonna be our screenshot instead of the test image. And then this util found kill is just gonna flash our hue light and do whatever else we want. So say if we wanted a sound coming out of it, that's where we'll do it at. All right, so we're playing Team Rumble because I do need multiple kills. I wanna get 3 to 4 tests. And I kinda want it to be perfectly working. Like I don't want any test to be missed out on. If a test is missed out on, I kind of wanna go back and figure out what's going on. Cause this is our DIY game API. DIY game API. And when we have an API, it needs to be kind of perfect or close to it. It can't just be missing out on different kills and stuff like that. That's crazy. Oh, shoot. I'm getting too excited. Finally got a kill. It's been taking forever. I guess that first game was a fluke, is what you want me to say. And you know what? This game was a fluke. 2. That's 2 confirmations. Let's see if we can get 2 more before this game is over. 3. This game is lagging like crazy. And I have a feeling that it has a lot to do with... Alright, okay, that was bad. I only got 3 kills. So we're gonna run 1 more game. I wanted to get more confirmations. Even though all 3 worked, I wanted to get at least like 4 to 5 confirmations. So I'm gonna run 1 more game real quick. But anyway, while in the meantime, the reason why this is so CPU performant right now, or CPU heavy, is that we are scanning the whole screen. So we're going from the top left of the screen all the way to the bottom right of the screen. And that takes a lot of time and it takes a lot of CPU work. One way around that is that we find, since we know where our eliminated sign is gonna be, it's gonna be in the bottom center of the screen. Instead of checking the whole screen, we could change it to just check that section, and it'll only be checking that little section, and it'll be done. And it'll check again, it'll be done. And we could probably get like 30 to 60 frames per second if we did it like that way, versus checking the whole screen, which is probably gonna give us like 5 to 15 frames per second. Another way is that we make sure that we're using edge detection, which is just gonna be black and white, and that's gonna be a lot less CPU heavy as well. Right now we are using grayscale, which is already a big load off of using just color. because color has, what, 3 different channels that it has to check for. So there's a lot of ways we can get more CPU performant, or more performant in general. Yeah, this is a new game, new area. Make sure everything is still working. Got him. That's 4 so far. There it is. There's my 5 that I was looking for. 6. Honestly, I thought there may be 1 or 2 flukes, 1 or 2 outliers, but it looks like picking up all of them. Yeah, baby. Yeah. What's that? I can't even keep track of how many confirmations we have now. I think that's, what, 9? 9 confirmations? Got him! Got him. And if you can't tell from the screen, you can tell from over here. Oh, shoot. That's funny. That's funny. 8 kills, not too bad, not too bad. And each one of the kills worked. I'm so happy. I'm happy. I'm extremely happy. Now to close out DIY Games API, we will be continuing this series dealing with different games and as well as different parts of games. So it's not gonna always just be a kill or a goal. We're gonna be digging into more things that we do in games to make them more interactive and fit our needs. See, as you've seen, template matching is very useful for things that are gonna be static and consistent. If we needed more power, we'll dig into either hard cascades or convolutional neural networks if we want the most power, and we'll probably dig into that as well at some point. Anyway, let me know what you all think about DIY Games API. We definitely want to continue this series. And this series would be good filler in between when we're working on a bigger project where we need more weeks. So we have something in between those weeks. Right now I have a big project going on that I'm hoping to complete in the next few weeks. I got a little better at this. Make sure you like, comment, and subscribe, and I'll see y'all next time. DIY Games API.
DIY Games API.